So find the velocity. What is the velocity after 3 seconds? When is the particle at rest? When is the particle moving in the positive direction? Find the total distance traveled during the first 8 seconds. Draw a diagram, we'll see. Find the acceleration and graph, and then when is the particle speeding up and when is it slowing down? So a lot of questions. So let's copy the function that is given to us. So this is f of t, which is t to the third minus 12t squared plus 36t. So this is the equation of motion. It's a law of motion. So this is measured in feet. It's the distance. And time, of course, is greater than or equal to 0. And is measured in seconds. Okay. First question, part A, is asking us to determine the velocity at time t. So in order to find the velocity, so this is also denoted by s, or if you want s of t to be exact. So in order to find the velocity, I will definitely have to differentiate the distance, because the velocity is the rate of change of distance with respect to time. All I have to do is apply the differentiation rules. So I have 3t squared. I bring down 2 minus 24t and plus 36. And basically that answers part A. Part B. What is the velocity after? Yes, please. Yes, go ahead.
So what is under t is greater than or equal to 0? What does that say?
In seconds. T is measured in seconds.
Thank you.
Thank you. So part B. Find the velocity after 3 seconds. That's not a problem. All I have to do is plug in 3. And I have 3 multiplied by 9 minus 24 multiplied by 3 and plus 36. Since I'm lazy, I'm going to use a calculator. So I have 27 minus 24 times 3 and plus 36. Let me see if I have that correctly. Yes, perfect. And I got negative 9. I have to write the measurement unit, and we have to talk about what it means. Can anyone give us the measurement unit?
Feet per second.
Very good, thank you very much. Feet per second. And the question is now, why is it negative? Can I ever drive with a negative speed? The answer is no. I cannot drive with a negative speed, but why is it negative? So when the particle moves in this direction, we consider the speed to be positive. When the particle is going this way, we consider the speed to be negative, v of t to be negative, v of t. So it only says that the particle is coming back, is not moving away from where it started, but it's coming back towards the point of origin, if you want. Part C. When is the particle at rest? Particle at rest. When? So the question is, what does that mean? What am I really asked to determine? When is your
velocity 0?
Thank you very much. When v of t is 0, all I have to do is plug it in, which is 3t squared minus 24t and plus 36 equals 0. So we are at rest when the velocity is 0, or the particle is at rest when the velocity is 0. Okay, so we have to solve this equation. Of course, I'm all about simplifying, so what do you think I am going to do first thing?
Take out 3.
Very good. Simplify dividing by everything by 3. So I will not factor it out because it's an equation. But if it were an equation, I would have to pull it out. But in this case, it's not. It's an equation. I can get rid of it immediately. So t squared minus 8t and plus 12. If factoring takes longer than 20 seconds, then forget it. But it doesn't. It's t minus 2 and t minus 6. So we have two options for t equals 2 seconds and t equals 6 seconds. So the velocity is 0 at t equals 2 seconds and at t equals 6 seconds. Part D, when is the particle moving in the positive direction? Particle moving in positive direction. I don't know, but I know how to study the sign of v of t. So v of t is given to us, and this time I have 3, t minus 2, and t minus 6. Which is the same with the non-factored form, but I have to use the factored form if I decide to study the sign. If I have to study the sign, I have to use the factored form. And we've done something similar a while back for a square root. X is the sorry, it's not x, it's t. Not a big deal, but I want to keep the variable that we have in the problem. So this is t. The first factor is t minus 2. The second factor is t minus 6. And what I'm really interested in is in the sign of v of t. The 3 doesn't matter. Anywhere I put it, it's still not going to change the sign. We already know from part C that, of course, 0. I'm only rushing to write negative infinity to infinity, but for this is not the case. We'll talk about time. So we have 2 and 6. T minus 2 is 0, of course, at 2. T minus 6 is 0, of course, at 6. We already know that the velocity is 0, as we just determined in part C, at 2 and 6. If you remember what we did last time when we studied the sign, these two are linear functions with a positive slope, meaning they come from negative, they cross the x-axis, and they go positive. Both of them. You don't have to do this, just plug in numbers. And you will see this is negative and then positive after 0. This is negative before 0 and positive after 0. So now this is a product. If it's not a product or a ratio, I cannot use this table. If I don't have 0 on one side, I cannot use the table, of course. So when I multiply two negatives, I get a positive. When I multiply a negative by a positive, I get a negative, and then positive. So I can say that particle moves in positive direction for time in the interval 0 to union 6 to infinity. Since I already see it here, particle moves in negative direction for t in the interval. Can anyone tell us? Very good. So basically what the particle is doing, according to our discovery, is this. Starts at 0, goes to the right 2 seconds, right here, 2, then turns around and moves to the left 6 seconds, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it goes this direction for 2 seconds, this direction for 6, but that 2 plus 6 will be at 8. And Oh, I'm sorry. It's 6, so 6 seconds, right? So it turns around at 6. Yes. 1, 2, 3, 4, 5, 6. Yes. So 1, 2, 3, 4, 5, 6. Right here. At 6, it turns around and goes that way. So between 0 and 2 in the positive direction, between 2 and 6 negative direction, and between 6 and infinity in the positive direction. So this is at time 0, this is at time 2. For 4 seconds goes this way, this is time 6, and at 6 turns around and goes to the positive direction. Okay, part E. Find the total distance traveled during the first 8 seconds. So E, total distance for time between 0 and 8. So that's why I put the graph in there, because the total distance will be the absolute value. You can say when it's going in the positive direction, you don't have to put the absolute value. That's true. But let me just show the whole thing with the absolute value, and then we can drop when we don't need it. So f of 2 minus f of 0 is the distance covered by the particle between time equals 0 and time equal 2. S of 2 minus S of 0 is that distance. Now plus S of 6 minus S of 2. And plus, because we want to stop at 8, S of 8 minus S of 6. So the particle accumulates distance no matter what. Okay, I put F and S. They are the same, but I want to be consistent. Same thing. We wrote both at the very beginning. We wrote S on F. Same thing. Okay, so then I will plug them in. So I will plug in Y equals. I will put in t to the third power and minus 12t. I don't have t, I have to use x. And plus 36t. And then second and table. And I'm going to plug in 0, 2, 6, and 8. And I'm just going to copy them now. S of 2, 0, 2, 6, and 8. Okay, S of 2, so that will be 32 minus 0, plus S of 6, 0 minus 32, and then plus F of 8, 32 minus 0, minus F of 6. So the absolute value is 32 plus 32 and plus 32, so this is 96, and the measurement unit is feet. So the total distance covered by the particle in the first 8 minutes is 96 feet. The reason why we use the absolute value is because no matter which direction the particle is going, it will accumulate distance. Okay, draw a diagram. We already did. That's the diagram. Find the acceleration at time t after 3 seconds. So this was F. And this is a G. Yes, it is. Next one is G. I make sure that I didn't go over anything. So find acceleration at time t and also after 3 seconds. So A of t is the first derivative of the speed, or the second derivative of the distance. So I have the velocity, so that will be, I bring 2 down, so this is 6t, and then minus 24. We're asked to find the acceleration at time 3, at time t equals 3. So then I have 18 minus 24, which is negative 6, measurement unit for acceleration. Remember, is the rate of change of velocity with respect to time. Measurement unit. Anyone? Measurement unit?
Feet per second squared.
Very good. Measurement unit of the, it's a rate of change of velocity with respect to time. Awesome. Last question here. They want us to determine when is the particle speeding up and when it is slowing down on 0 to 8. So the graph is h. We're going to graph with a graphing calculator. But the last question is, when is the particle speeding up or slowing down? Okay, so that's an analysis that is very important to understand.